So in chapter 4, we'll study number theory. So this is a key point for computer science field. The key ideas of number theory is the divisibility and the primality. شو معناها primality? Prime numbers. تعرفوا شو معناها prime number? You don't know what the meaning of a prime number?
مو اللي دكتور شو اسمه 2 3 5 7.
هاي هذوكم هم. These are prime numbers. عدد الأولية. Okay. Representation of integers in a binary system in a decimal system. Okay. شفنا الباينري system decimal system اللي تستعملوا فيه من الابتدائي. Okay. All these are part of number theory. So in this chapter regarding the textbook, if you are using the textbook, we'll study only section 4.1 about divisibility and modular arithmetic. هذه راح نشوفها اليوم. And section 4.3 about prime numbers and GCD, greatest common divisors. Okay, so we'll focus on these two sections of chapter 4. So today, let's study divisibility and modular arithmetic. So we'll define the division, introduce the division algorithm, and define the concept of modular arithmetic, very important in a binary system, for example. So the division, we say that if A and B are two integers, so number theory only deals only with integers. Okay, so in this chapter, we'll deal only with integers. Okay, that's صحيح. With A non-zero to be able to divide, because you all know that no division by zero. So we say that A divides B if we can write B as A times C. If we can find an integer C such that A times C equal B. When A divides B, we say that A is a factor or a divisor of B, and B is a multiple of A. For example, 5 is a divisor of 20. Okay, 5 divides 20 because we can write 20 as 5 times 4. Okay, this is, you can find the constant an integer C such that AC is B. Okay, and we denote that A divides B. 5 divides 20. Okay, 10 divides 150. This is the symbol for the division. But however, 3 does not divide 20. Okay, we cannot find an integer such that 3 times this integer is 20. Such an integer doesn't exist, so 3 doesn't divide 20. So, does 3 divide 7? Of course, the answer is not. Does 3 divide 12? The answer is yes. So 3 is a factor of 12 or divisor of 12. So some properties, if A divides B and A divides C, then A divides the sum. مثلا 5 divides 10 and 5 divides 15. So we can say that 5 divides as well 25. Okay? If it divides A, B and divides C, divides the sum. If A divides B, then A divides any multiple of B. Okay? So if 5 divides 21, مش 21, مش 5. 7 divides 21, so 7 divides 42 as well. 7 divides 63 as well. Okay, any multiple of 21. If A divides B and B divides C, then A divides C. So, any example? 3 divides 9, and 9 divides 36. So, this means that 3 divides 36 as well. So, if A divides B as a consequence, if A divides B and A divides C, then A divides any linear combination of B and C. So 3 divides 6 and 3 divides 9. So we can say that 3 divides 2 times 6 plus 5 times 9. Okay, any combination, linear combination of these two integers. So هذه means that 3 divides 57 as well. The division algorithm. So when an integer is divided by a positive integer, usually there is what we call a quotient and a remainder. Okay? So for example, if you divide 17 by 3, what is the result? إذن هو 5, but 5 times 3 is 15. 17 minus 15 يبقى 2. Okay? So this is called the quotient, and this is the remainder, باقي القسمة. And this is a division algorithm. We say that 17 is 3 times 5 plus 2. This is the remainder, and this is the quotient, and this is a division algorithm. So we write A equals D, the divisor. The divisor here is 3, okay? Q is the quotient 5, and R is the remainder 2. So D is the divisor, Q is the quotient, and R is the remainder. And we write Q is A div D. Okay, so in the previous example, on 17 over 3 is 5 and the remainder is 2, we say that 5 is 17 div 3. 5 is the quotient of the division of 17 by 3. That 2 is 17 mod 3. So 17 mod 3 is 2. Why 2? Because 2 is the remainder of the division of 17 by 3. Okay, so the mod function تعطيني the remainder. Okay, the div function تعطيني the quotient. So what are the quotient and remainder when 101 is divided by 11? So we do the division. 101 by 11, that in a 9 point something. 999, 101, so 2. Okay, we can say that 101 is 11 times 9 plus 2. This is the quotient. This is the remainder. Okay, so we can say that 101 mod 11 come. So mod here remainder باقي القسم, it's 2. 101 div 11 is 9, the quotient. Okay, so for positive integers, when A is positive, this is easy. It's a bit more complicated when A is negative. ليش؟ لأنه هنا اللي ما حكيت عليه إنه reminder R must be non-negative and less than D. Okay, this is very important. Now, a congruence relation. Okay, what's the congruence relation? So if A and B are integers, M is a positive integer, we say that A is congruent to B modulo M, and we denote it in this way. A is congruent to B mod M if M divides A minus B. Okay, if A minus B mod M is 0. The remainder is 0 when you divide A minus B by M. This is called the congruence. Okay, the congruence relation. And M is the modulus of this congruence. If A is not congruent to B modulo M, we write A not congruent to B mod M. So is 17 congruent to 5 modulo 6? هل 17 congruent to 5 mod 6? Yes or no? Okay.
نو يا دكتور.
لا. Yes, it is. Why? Because
مو بلما تصير 12.
17 minus 5 كم؟
أو صح صح
12.
12. يس يس.
Mod 6 is 0. So yes, 17 is congruent to 5 mod 6. شو معناها congruent؟ congruence معناها إذا تقسم 17 على 6 تعطيك 2 الباقي 5. إذا تقسم 5 على 6 تعطيك 0 والباقي 5. So they have the same remainder when you divide by 6. Okay, this is another characterization. 17 mod 6 هي نفسها 5 mod 6. Okay, if this is true, then they are congruent modulo 6. هل 24 and 14 are congruent modulo 6؟
لا يا دكتور، لأن
نسوي
إذا نقصناهم
24
تصير 10.
minus 14 10.
ما
10
تنقسم
mod
10 على
6
6.
بكم؟ كم 10 mod 6؟ What is 10
10.
mod 6؟ لا 10 mod 6 كيف نجيب المود؟
10 مود 6.
هاي 10 mod 6 لازم تشوف الريمايندر 10 على 6 بواحد. كم الباقي؟ كم الباقي هنا؟
4.
4. So 10 mod 6 or 24 minus 10 mod 6 is 4. It's not 0. Okay, this means that 24 is not congruent to 14 mod 6. Okay, أو 24 mod 6 كم؟ 24 mod 6 هي 0 لأنه 6 divide 24, but 14 mod 6 is 2. Okay, so they are different. Okay, so 24 is not congruent to 14 mod 6. إذن اللي يهمنا هو reminder، باقي القسمة في الكونجرينس. اتفقنا؟ So again, 17 is congruent to 5 mod 6 because 6 divides the difference 17 minus 5, but 6 does not divide 10, 24 minus 14. So if A and B are congruent modulo M, if A is congruent to B mod M, okay, then we can write A equal B plus Km. Okay, this is the relationship, not very important. But what is important is the relation between the mode function and the congruence. Okay, and here we can say that if A is congruent to mod M, then A mod M equals B. Okay, the remainder of the division of m of a by m is b when b is in the case, of course, here when b is positive and less than m. Okay, it's the remainder of the division of um, a by m. اوكي، مثلا 15 على 6 تعطيني 2، الباقي 3. So 15 mod 6 is 3. This means that 15 is congruent to 3 mod 6. Okay, this is the relationship between the congruence and the mod functions. Okay, get it؟ من ما فهم لسه العلاقة بين الاثنين واضحة؟
واضحة.
اي واضح.
اوكي، needs a bit of practice. ما شفتوها قبل الكونجرينس، هذه أول مرة صح؟
اي هذا اول مره.
تمام. So A mod M equal B mod M حكينا عليها هذه. Is 15 congruent to 3 mod 12? The answer is yes. So we can see it in different ways. نقولوا إنه 15 minus 3 is 12.
12.
So this is 12. So mod 12 is 0. So it's fine. Or you say that 15 mod 12 here, 3 with 3 mod 12 here, 3. So they are the same. So it's also fine. Okay. So another property, if A is congruent to B mod M and C is congruent to D mod M, then A plus C is congruent to B plus D mod M. Okay, and the product as well, AC is congruent to BD mod M. So مثلا, we know that 7 is congruent to 2 mod 5, that 11 is congruent to 1 mod 5. So the remainder of the division of 7 by 5 is 2. The remainder of the division of 11 by 5 is 1. So we can say that the sum 18 is congruent to 3 mod 5, and that the product 77 is congruent to 2 mod 5. Okay, this is the sum. This is the sum. This is the product. This is the product. So these are some properties of the mod function. So in algebra, multiplying both sides of a valid congruence by an integer preserves validity. So if A is congruent to B mod M, multiplying by C both sides, you get valid congruence. Okay, مثلا 13 is congruent to 3 mod 5. So this means that 26 is congruent to 6 mod 5. Okay, multiplying by 2, that 39 is congruent to 9 mod 5. So all these are properties of this congruence function. Adding an integer to both sides preserve validity. So multiplying by same constant or adding the same constant gives you a valid congruence, but dividing is not working. Okay, this is an example. 14 is congruent to 8 mod 6, but 7 is not congruent to 4 mod 6. Okay, so when you divide by 2, it's no longer valid. Okay, you can multiply by the same number, you can add the same constant, the same integer, but you cannot divide by the same integer. This is another relationship. So A plus B mod M is A mod M plus B mod M, all mod M, and the product as well. What does it mean? It means that here we can add minus 133 plus 261 since we have the same mode. Okay, we add them and we get, I don't know, 128. So this is 128 mod 23. Okay, and you can calculate 128 mod 23. It's 5. The remainder is 13, so this is 13. Okay, so you can combine here in this way the product as well. Now arithmetic modulo M, how to add and how to multiply when you have a congruence modulo M. So here for the congruence, we work on a new space, a quotient space, it's called Zm. So the element of Zm are from 0 to m minus 1, which are the remainder of the quotient. Okay, and the remainder is always non-negative and less than m, and it's an integer. So يا اما 0 1 2 حتى m minus 1. These are the elements of this space. Then Z2 فيه كان 0 and 1. Z5 فيه 5 elements اللي هو 0 1 2 3 4. These are the possible remainder. Okay, and in this space we define this addition modulo m. It's not the classical addition. Okay, if you do the classical addition, 2 plus 4 is 6, is not in Z5. Okay, لازم the sum must be an element of Z5. Okay, it must be closed under addition. So we define the addition modulo m in this way. It's a plus b mod m. It's the remainder of the sum of a plus b. Okay, it's not the sum of a plus b, but it's the remainder of the sum of a plus b divided by m. The same for the product. A multiplication modulo m, this is the operation by b, it's ab mod m. Okay, so let's see some example. What is 7 plus modulo 11 9. Okay, قلنا هذه شو راح تعطينا. This is the definition. It's 7 plus 9 mod 11. So it's 16 mod 11. كم 16 mod 11? 16 mod 11. So 16 على 11 1 والباقي 5. So it's 5. So 7 plus modulo 11 of 9 is 5. مين يتخيل انه 7 مع 9 تعطيني 5. Okay, so for this algebra 7 plus modulo 11 of 9 is 5. Okay, غريبة شوية واحنا مش متعودين، لكن this is how we add here. اللي يهمنا هو باقي القسمة in this algebra.
أنا والله ضعت شوي دكتور.
ما هي وين ضاعت، في هذه ولا في اللي قبلها؟
لا لا هذه
this is the definition. كيف نعمل 7 multiplication modulo 11 of 9. قال لي هذه by definition it's 7 times 9 الضرب العادي mod 11. اوكي 7 times
أوكي
9 هي كم؟ 63 mod 11. كيف نجيب 63 mod 11؟ قلنا نقسم 63 على 11. كم 63 على 11؟ 5. كم الباقي؟
8.
8. ف 7 multiplication mod 11 of 9 is 8. The result is 8.
أوكي
Okay. هو باقي
يس.
القسمة متاع الضرب، وباقي القسمة متاع الجمع باي ذا موديولو.
اوكي.
هذا إذا بوزيتيف، إذا نيجاتيف أصعب شوية. أوكي، راح نشوف example. So this new addition and new multiplication satisfy many of the properties of the ordinary addition and multiplication اللي متعودين بهم. So it's closed. So the sum modulo m and the multiplication modulo m are still elements of Zm, or the quotient space. It's associative, it's commutative, so the order is not important. A plus modulo mb is b plus modulo ma. ترتيب مش مهم في الضرب في الجمع. The identity، إذا تضيف صفر للاديشن موديلو ام يعطيك نفس العدد، إذا تضرب في 1 يعطيك نفس العدد موديلو ام. The additive inverse، مثلا 3 plus 8 plus modulo 8 of 5 equals 0 لأنه مجموعهم 8. أوكي. 11 plus modulo 17 of 6 is 0. أوكي، لأنه مجموعهم 17، لأنه 17 على 17 الباقي صفر. أوكي. This is the additive inverse. Okay. And we can as well distribute or take common factor زي ما متعودين. So all this operation, all these properties are still valid.